In this session, we are going to discuss about production of calcium phosphate. There are three types of calcium phosphate. One is superphosphate, another one is triple superphosphate, and third one is sodium phosphate. Before discussing that, today's topics, we just recall what you have studied in the last session. In the last session, we have discussed about the production of urea by total recycle process or by ammonium carbamate decomposition process and production of ammonium sulfate and ammonium phosphate. In the production of urea, it starts with raw material like carbon dioxide and ammonia. This ammonia and carbon dioxide are compressed and fed to an autoclave, which is operating at a temperature of 180 degrees Celsius and a pressure of nearly 180 to 190 atmospheres. At such a high pressure, the ammonium carbamate is formed along with a mixture of unreacted ammonia, unreacted carbon dioxide, and water formed because of the reaction. All these mixture are actually cooled and fed to a flash evaporator which is operating at 140 degrees Celsius and at a pressure of 27 atmospheres so that the ammonium carbamate actually decomposes and forms urea, and this is then actually fed to flash drum which is operating at 1 atmosphere pressure to separate ammonia and carbon dioxide from the urea, and the urea concentration is obtained around 80% in this flash drum which is operating at 1 atmospheric pressure, and then this urea is fed to vacuum evaporators which is operating at a temperature of 135 degrees Celsius to concentrate this 80% urea solution to 99% urea solution, and the temperature of the urea is to be maintained just above the boiling point of urea to avoid the formation of biuret. Then this urea solution is then sprayed from the top of the drilling tower in countercurrent to the cooling air or conditioned air which is fed at the bottom of the tower, where the droplets from the top of the tower get solidified when they reach to the water. The urea thus formed is in the form of granules or prills, and that is actually cooled and then bagged. In the production of ammonium sulfate and ammonium phosphate, in the case of ammonium sulfate, the sulfuric acid is neutralized with ammonia so that ammonium sulfate is formed, that is monoammonium sulfate and diammonium sulfate. Similarly, when phosphoric acid is neutralized with ammonia, it produces monoammonium phosphate and diammonium phosphate. and then these phosphates are actually granulated, dried, and bagged. When the mixed fertilizer is desired, both phosphoric acid and sulfuric acid are neutralized in the same tank together, and the mixture of ammonium phosphate and sulfate are formed. To this, potassium chloride KCl powder is added and then granulated in the granulator and then dried and bagged to get the mixed fertilizer. So, and we have also seen the flow diagrams for urea production and for ammonium sulfate and ammonium phosphate manufacturing. We have seen their properties and applications. In today's session, we are going to discuss about the calcium phosphates. Low grade calcium phosphates are made as fertilizers. The two distinct grades based on the method of production from phosphate rock are: number one, superphosphate, made by reacting phosphate rock with sulfuric acid and which contains 16 to 20% phosphorus pentoxide. The another one, triple superphosphate, which is made by reacting phosphate rock with phosphoric acid, and it gives a product which contains 42 to 50% phosphorus pentoxide. So in triple superphosphate, the phosphorus pentoxide content is 3 times than that of superphosphate, hence it is called triple superphosphate. First we'll discuss about the production of superphosphate, how it is produced, what are the raw materials, what are the chemical reaction occurring. We'll see these one by one. Raw materials: a high grade phosphate rock which contains 30 to 35% phosphorus pentoxide is required. Dilute sulfuric acid of 62 to 70% concentration is required. The chemical reaction: the phosphate rock reacts with sulfuric acid and gives calcium phosphate, that is superphosphate, that is 3CaH4BO4 twice 7CaSO4. In total, it is called as superphosphate and hydrogen fluoride. The hydrogen fluoride is removed by using silica. Hydrogen fluoride 4HF plus SiO2 gives H2O plus SiO4, sorry, SiF4, that is silicon fluoride. The silicon fluoride then treated with water which produces hydrogen silicon fluoride and silica. This hydrogen silicon fluoride with sodium chloride gives sodium silicon fluoride. This is the flow diagram which is used to produce superphosphate from phosphate rock and hydrochloric, sulfuric acid. Let us see the process. Rock phosphate is crushed in a jaw crusher and ground to pass 100 mesh screen. A continuous feed of dilute sulfuric acid, 65 to 70% concentration, and powdered rock phosphate is fed to a steel trough, lead lined and brick lined, to avoid the corrosion of the reaction vessels covered with a hood to collect silicon fluoride and hydrogen fluoride fumes. The content is mixed and moved gradually forward at a rate of zero point 0.2 to zero point 0.5 meters per minute in a reactor conveyor. With proper grinding and acid control, the reaction is effectively complete and sent to a granulator. The porous, crumbling material from the den is mixed with rock dust from the grinding section. The content is fed to a sloping rotary drum where water is sprayed on the tumbling solids to form free flowing granules and to enhance the acetylation reactions. The product is dried in a rotary drum dryer and packed in plastic lined jute bags. So this is the process which is taking place in the production of superphosphate. Now we see the production of triple superphosphate. Raw materials required: high grade phosphate rock here also, that which contains 30 to 35% phosphorus pentoxide and concentrated phosphoric acid. The chemical reaction: phosphate rock reacts with phosphoric acid and produces triple superphosphate. The process: a process similar to superphosphate production is used here. The acid, that is phosphoric acid, at 60 to 70% concentration at the same temperature is mixed with ground rock phosphate in a continuous mixer and passed to a continuous belt reactor where the reaction is completed within a time of 15 to 20 minutes. The product is next granulated, dried, and bagged. If more complete fertilizer is desired, excess sulfuric acid is used and neutralized with ammonia, and potassium salts are also added. Potassium salts means potassium chloride is also added to this. This is the flow diagram for the production of triple superphosphate. We see the production of tripoly sodium tripolyphosphate, right? Ortho and polyphosphates are made from varying ratio of sodium carbonate, sodium hydroxide, and orthophosphoric acid. The chemical reaction involved is sodium carbonate reacted with phosphoric acid gives sodium tripolyphosphate Na2P3O10, water and carbon dioxide. Let us see the properties. Its molecular weight is 368. Solubility is 12.8 grams per 100 cc of water at 20 degrees Celsius. It is obtained in the form of white powder. The pH of the solution, that is sodium tripolyphosphate solution, is 9.7. The various structures of sodium tripolyphosphates, depending on the sodium content: metaphosphate, hexametaphosphate, that is polyphosphates, pyrophosphates, orthophosphates, etc. where X in this equation is alkali metals such as sodium. This is the flow diagram for the production of sodium tripolyphosphate process. Saturated soda ash solution and concentrated phosphoric acid are diluted with water and steam is mixed in the tank. A ratio of around 1.67 of sodium oxide to phosphorus pentoxide must be attained to form 1 mole of monosodium and 2 moles of disodium phosphate. Carbon dioxide comes off and is scrubbed with water to separate the entrained solids for recycling. The solution is filtered to remove impurities and dried, dehydrated, annealed, and cooled in a rotary plate. Grinding, storage, and packing completes the process. Then applications. Sodium tripolyphosphate is used in the production of soaps and detergents, in the metal cleaning, in boiler feed, water treatment, in textile industries, and in food stuffs. So these are the applications of sodium tripolyphosphate. Friends, we have discussed about the production of superphosphate, triple superphosphate, sodium tripolyphosphate, and we have seen the applications of those. Now we see some objective type questions. Question number one, phosphatic fertilizer is graded on its dash content. The options are P2O5, option B PCl2, option C P2O3, option D none of these. The answer is option A phosphorus pentoxide. Second question, superphosphate is manufactured by reacting phosphate rock with dash acid. Options are A acetic acid, B sulfuric acid, C ammonium chloride, and D phosphoric acid. Option B is the right answer, that is sulfuric acid. Next question. Triple superphosphate is made by reacting dash. Options are A phosphoric acid, B sulfuric acid, D hydrochloric acid, and D nitric acid. So the right answer is option A, that is phosphoric acid. Next question. Triple superphosphate is made from dash. Ca2, 3Ca3, PO4 twice. Option B, 3Ca3, PO4 twice. Option C, CaPO4 twice. Option D, CaH2, PO4 twice. Answer is option A. Next question. Ammonium phosphate is made and known as dash fertilizer. Option A nitrogenous fertilizer. Option B phosphatic fertilizer. Option C complex fertilizer. Option D mixed fertilizer. Option D is the right answer. Next, the phosphorus pentoxide content in triple superphosphate is about option R Option A 42 to 50%, option B 15 to 20%, option C 20 to 25%, and option D 25 to 40%. Option A is the right answer. Thank you.